On the night of Sunday, June 21st, 2026, a single line of storms swept out of the plains and ran for hundreds of miles before morning. It started as scattered thunderstorms in southwest Kansas. By the time it reached Oklahoma after midnight, it was throwing wind gusts past 100 miles an hour and pulling homes down to their foundations. This kind of storm has a name. Forecasters call it a derecho, a windstorm that travels in one long, damaging path rather than spinning in place like a tornado. If you want calm, clear reports on storms like this one, you can follow along. What makes this storm worth a closer look is not the storm by itself. It is the month around it. June of 2026 has produced damaging wind reports at the second fastest pace on record, going back to 1955. 3 people were killed in this latest round. More than 500,000 homes lost power in an earlier blow. This report walks through where the storm began, what it did, why this June kept reloading, and what that record pace really means. The first reports came in from southwest Kansas just after dark. A line of thunderstorms had built along the edge of the summer heat, and within an hour it was snapping power poles and tearing limbs from trees. By the time most of the region had gone to sleep, that scattered line had pulled itself together into one long, fast-moving storm. It did not stop at a county line. It did not stop at a state line. It pushed east through the dark, and by sunrise it had carved a path of damage across parts of 3 states. What ran across the plains that night was a derecho. The word comes from Spanish, and it means straight ahead. That is the plainest way to hold the idea. A tornado spins in one place and moves on. A derecho runs in a straight line, shoving a wall of wind ahead of it for hundreds of miles. It is less famous than a tornado, and often does more total damage, simply because it covers so much ground in one sweep. The storm reached its worst over Oklahoma after midnight. Near the town of El Reno, just west of Oklahoma City, the wind topped 100 miles an hour. Homes that had stood for decades lost their roofs in seconds. A few were pulled down to bare slabs. About 100 miles to the northwest in Woodward County, the wind was strong enough to push a freight train off its tracks while people slept nearby. Then the same system swung northeast and crossed into Illinois. There the damage turned deadly. In rural Jefferson County, about 90 miles southeast of St. Louis, the storm destroyed 2 mobile homes that sat a few miles apart. 2 people inside them were killed. A third home was flattened, and 5 more people were hurt badly enough to go to the hospital, though their injuries were not life-threatening. By the time the count was settled, 3 lives had been lost across the night. These are the kinds of numbers that can wash past a listener, so it helps to slow down. 1 storm. 1 night. A train knocked off its rails, homes pulled apart in 2 states, and 3 families changed for good. The wind that did this was not a tornado. No funnel touched down at those mobile homes. It was straight-line wind, the steady, battering push of a derecho, and it can level a small structure just as surely as a twister can. By Monday morning, the threat had moved on. The storms weakened and shifted east, toward the mid-Atlantic and the southeast, where they would fade into ordinary summer rain. The plains in the Midwest were left to clean up. Crews started clearing roads. Utility workers started raising poles. Survey teams from the National Weather Service began walking the damage to measure what had happened. Their early read was clear. The wind path was long enough and strong enough to meet the official definition of a derecho, a finding they marked as preliminary, while the survey continued. On its own, a single derecho is a serious storm but not a rare one. The plains in the Midwest see a few every summer. What made this one stand out was not the storm by itself, it was the company it kept. This was not the first major windstorm to cross the region in June. It was not the second. It landed at the end of a stretch of weeks that had already pushed the season into unusual territory, and that is the part worth sitting with. That is what this report is about. It is about one storm, told in order, from the first gust in Kansas to the damage in Illinois. It is also about the month that storm belonged to, a June that kept reloading the same kind of weather again and again across the same tired region. To understand why the night of the 21st hit the way it did, it helps to go back to where the line first formed, out on the dry edge of the heat in western Kansas, hours before anyone in Illinois had reason to worry. So that is where this begins. Not with the loudest moment in Oklahoma, and not with the loss in Illinois, but with the quiet hour before any of it, when a few thunderstorms started to grow in a place that had been hot and still all day. The conditions that fed them had been building for some time, and they tell you most of what you need to know about the night that followed. The starting point was the dry country of southwest Kansas, late on a Sunday afternoon. The ground there had baked under a strong sun all day. The air near the surface was hot, and a few miles up it was cooler, which is the simple recipe for a thunderstorm. Warm air wants to rise. When the air above it is cool enough that rising does not stop, it builds upward into a tall cloud and a storm is born. Two ingredients turned ordinary storms into something larger that evening. The first was fuel. A ribbon of warm, moist air had pushed north from the Gulf and settled over the plains. Forecasters measure that fuel as energy in the air, and on this evening there was a great deal of it. The second ingredient was wind that changed speed and direction with height. That kind of layered wind gives a storm structure. It lets a storm stand up tall and organized instead of collapsing on itself. The Storm Prediction Center had seen this coming. That office, run by the National Weather Service in Norman, Oklahoma, watches the whole country for severe weather and draws maps of where the risk is highest. For this Sunday, those maps had flagged the Central Plains for days. The wording was careful and clear. Widespread damaging wind was the main concern. A few tornadoes were possible. The risk was real, but not framed as the end of the world, which is the right tone for a forecast like this. The first storms went up in the late afternoon and looked unremarkable at first. They were tall and bright on radar, but they stood apart from one another. That changed as the sun got lower. One by one, the separate storms began to merge. Their cool downdrafts, the rushes of rain-chilled air falling out of each cloud, started to pool together along the ground. That pool of cool air acted like a plough. It lifted the warm air ahead of it and fed new storms along its leading edge. This is the quiet mechanism behind almost every derecho. A single storm drops cool air. That cool air shoves the warm air in front of it upward. The lift builds the next storm, which drops more cool air, which builds the next. The line feeds itself and starts to move as one body. Once that chain gets going on a warm, fueled-up evening, it can run for half the night before it finally runs out of warm air to eat. By the time darkness settled over Kansas, that chain had locked in. The first solid wind reports came from the southwest corner of the state. Gusts there were measured above 80 miles an hour, strong enough to bring down healthy trees and snap utility poles. To a person standing in it, 80 miles an hour does not feel like a gust. It feels like a steady wall leaning on the house, on the truck, on anything not bolted down. Nighttime did not calm the storm, and that is worth noting. Most summer thunderstorms fade after sunset, when the heat that fed them drains away. A well-built derecho can ignore that rule. It carries its own fuel forward in the form of that cool, ploughing air, and it taps into stronger winds that often sit a little higher in the night sky. So instead of weakening, this line held together and even picked up speed as it crossed into the dark. The people most exposed were the ones least able to see it coming. Many were already in bed. Phones were charging on nightstands. The warnings went out the way they should, as alerts that buzz and chirp. But a sleeping household does not always wake for them. That gap between a warning sent and a warning heard is one of the hardest problems in this kind of overnight storm, and it would matter a great deal a few hours later and a few hundred miles to the east. For now, though, the line was still over open country. It was gathering strength and aiming itself at the next state in its path. The worst of this storm was not in Kansas. It was waiting across the border, in the dark over central Oklahoma, where the wind would climb past the 100-mile-an-hour mark. The storm crossed into Oklahoma after midnight, and that is when it peaked. By the time it reached the area around El Reno, a town just west of Oklahoma City, the measured gusts had climbed past 100 miles an hour. That is a number worth pausing on. 100 miles an hour is the strength of a strong hurricane, only here it arrived inland, over dry land, in the middle of the night, with no warm ocean anywhere near it. In El Reno, the damage was concentrated and severe. City officials reported that 6 homes were badly hit. 3 of them were described in plain words by a city spokesperson as piles of rubble. That is what straight-line wind near 100 miles an hour does to a house. It does not always tear the building apart the way a tornado does. It pushes, steadily and hard, until a wall gives, and once one wall goes the roof, and the rest often follow. There is one piece of good news from El Reno worth saying clearly. No one there was reported hurt. The homes were wrecked, but the people inside lived through it. The city moved quickly afterward and arranged hotel rooms for 3 families who had nowhere to sleep. It is a small mercy inside a hard night, and it is the kind of detail that gets lost when a storm is described only by its wind speed. About 100 miles to the northwest in Woodward County, the wind found a different target. A freight train operated by the railroad company BNSF was crossing the county overnight when the storm hit. The wind pushed over a stretch of cars that ran for roughly a mile. The county sheriff described a long line of toppled cars left lying beside the track. Some of those cars carried placards marking hazardous material, which is the kind of detail that makes a first responder's stomach drop. The relief in this case was that no leaks were reported. The cars went over, but what they carried stayed inside. A train is a useful way to grasp the force at work. A loaded rail car can weigh well over 100,000 pounds. It sits low and heavy on steel wheels, built to stay planted. For wind to lay a line of them on their sides, it has to push with enormous sustained strength across a broad face. This was not a narrow twister catching one car. This was a wide river of wind leaning on the whole train at once, the signature of a derecho rather than a tornado. That difference is not just a technical note. It shapes how the damage looks on the ground and how survey teams read it the next day. A tornado leaves a narrow path, sometimes only a few hundred yards wide, with debris thrown in a swirl. Straight-line wind leaves a broad swath, often miles wide, with trees and debris all knocked down in roughly the same direction, pointing the way the wind was going. When investigators walked the El Reno and Woodward County damage, that broad one-way pattern was a large part of why they leaned toward calling it a derecho. The storms raked across central Oklahoma in the small hours and then began to turn. A derecho often bends to the right as it matures, curving like the top of a question mark. This one started swinging northeast, away from the open plains and toward the more crowded country of the Mississippi Valley. As it turned, it stayed strong, still throwing damaging wind, still feeding on the warm air ahead of it. Oklahoma had taken the hardest punch by the numbers, with that 100-mile-an-hour gust and the wrecked homes in El Reno. Yet Oklahoma, for all its damage, did not lose a single life that night. The worst human cost was still ahead, and it would come not from the strongest wind but from where the storm went next and what stood in its path. The line was now aimed at southern Illinois. Ahead of it lay small towns, open farmland, and scattered mobile homes that offered little shelter from a wall of wind. That is the part of the night that turned from property damage into loss, and it is where this story has to go next. The storm reached southern Illinois before dawn, and in rural Jefferson County it took 3 lives. The county sits about 90 miles southeast of St. Louis, in farm country dotted with small towns and isolated homes. The sheriff there, Jeff Bullard, gave a clear and sober account of what the storm did. 2 people were killed in 2 separate mobile homes that the wind destroyed. The homes stood 2 to 3 miles apart, so this was not one freak hit. It was the same powerful wind striking more than one place along its path. A mobile home is the hardest kind of house to protect in a storm like this. It is light. It often sits on a frame rather than a deep foundation. Strong straight-line wind can shove it, lift one side and roll it, and it can do that without any tornado at all. Officials across the storm zone kept returning to this point. The danger was not only the rare violent twister, it was the broad, battering wind, and that wind treats a mobile home with no mercy. The sheriff added more to the count. A 3rd home in the county was leveled completely. 5 other people were taken to the hospital with injuries that were not life-threatening. So the human toll in that one county came to 2 killed in the mobile homes, more people hurt, and at least 3 homes gone. Across the wider night, with the deaths and damage tallied from the plains through the Midwest, 3 people in all lost their lives. It helps to picture the moment without dressing it up. These deaths came in the dark, in the hours when people are deepest asleep. The warnings had gone out. Phones in those homes may well have buzzed. But a warning only works if it wakes you, and if you have somewhere safer to go once you are awake. In a mobile home in open country at 3 in the morning, both of those things are hard. There is often no basement, no interior room with thick walls, no sturdy building within reach. That is the cruel math behind these losses, and it is why officials say what they say. The standard guidance is worth repeating plainly, because it is built on exactly these kinds of nights. If you live in a mobile home and a strong wind threat is coming, the advice is to leave before it arrives. Go to a neighbour's sturdy house, a relative's home, a public shelter, any solid building with a small interior room or a basement. The time to move is the evening before, while it is calm, not when the wind is already at the door. Once the storm is on you, the safest spot left is the lowest, most interior room you can reach, away from windows. It is fair to ask why people stay. The answer is usually simple and human. The warning comes late at night. The forecast covers a wide area, and most of that area will be fine. Leaving feels like an overreaction right up until the moment it is not. No one in those homes did anything foolish. They were asleep in their own beds when a storm that had been building for hundreds of miles arrived over them in the dark. The loss in Jefferson County is the heart of this story, and it deserves to be held without spectacle. 3 people are gone, families are grieving, a handful of others are recovering in hospital beds. Those are not statistics to rush past on the way to the weather science. They are the reason the science matters at all. Forecasters study these storms so that fewer nights end this way. By morning, the storm had spent most of its strength and was sliding east toward the Appalachians, where it would break apart into common showers. The danger to the Midwest was over for that round. What it left behind was a long scar of damage from Kansas to Illinois and 3 empty places at 3 kitchen tables. To understand how a storm born in dry Kansas could still be killing people in Illinois at dawn, you have to understand the thing itself. The word derecho has come up several times now. It is time to slow down and explain exactly what it means, because the definition is precise, and that precision is part of why this storm earned the name. A derecho is a single, long-lived windstorm made of many thunderstorms working together. The National Weather Service uses a precise definition, and it is worth walking through, because the precision is the point. To be called a derecho, a storm has to produce a path of damaging wind that stretches at least 250 miles. Along that path, the wind has to gust to at least 58 miles an hour for most of its length, with several separate spots measuring 75 miles an hour or more. Meet those marks, and a cluster of storms graduates into a derecho. Those numbers are not arbitrary. 58 miles an hour is the threshold the Weather Service uses to call any thunderstorm wind severe. It is the speed at which healthy tree limbs start to break and minor structural damage begins. 75 miles an hour is the low end of hurricane strength, so a derecho, by definition, is a storm that holds at severe wind strength across hundreds of miles and rises to hurricane force in several places along the way. That is a high bar, and the Kansas to Illinois storm cleared it. The reason a derecho can keep this up comes back to the self-feeding chain described earlier. Most thunderstorms have a short life. They grow, they rain, their own cold downdraft chokes off the warm-up draft that fed them, and they die. A derecho turns that weakness into a strength. The cold air falling out of one storm does not kill the system. It plows forward, lifts the warm air ahead, and lights the next storm in line. The result is a kind of relay race that runs across the map, with each storm handing off to the next. Forecasters picture this leading edge as a gust front, the boundary where the rushing cold air meets the still warm air ahead. Stand in the open and you can feel a gust front coming before the rain. The wind shifts, the temperature drops. The sky ahead turns a hard, low grey. In a strong derecho, that gust front is where the most dangerous wind lives, a steady horizontal blast rather than a swirling one. There is a useful comparison here, and it is worth making once. A tornado is like a drill. It is narrow, intense, and it bores a tight path. A derecho is more like a snowplow blade. It is wide, it is heavy, and it pushes everything in front of it in the same direction. Both can destroy a house. They just do it with a different shape, and that shape is what survey teams read in the wreckage the next day. Derechos favour certain places and certain times. In the United States, they happen most often from late spring into summer, and most often across a band that runs from the southern plains up through the Midwest and into the Great Lakes. That is no accident. That corridor is where hot, humid Gulf air meets strong upper winds in the warm months, which is exactly the mix these storms need. The night of the 21st followed that pattern closely, forming on the dry edge of the heat and tracking northeast along the classic path. It is also worth saying what a derecho is not, now that the picture is clear. It is not a hurricane, even though it can match one for wind. A hurricane is a sprawling ocean storm that lasts for days and draws its power from warm seawater. A derecho is a creature of the land, born in an afternoon and usually spent within a day. And it is not a tornado, though it can spin up brief, weak tornadoes along its edge. Its main weapon is the straight push of the wind, not the twist. Knowing all this, the events of that night fit together cleanly. A line formed on the heat in Kansas, organised into a self-feeding system, held severe wind strength for hundreds of miles, peaked above 100 miles an hour in Oklahoma, and was still strong enough to take lives in Illinois by dawn. Every piece of that matches the textbook. The storm was unusual in its strength and its reach, but it was not mysterious. It did exactly what a derecho does. That raises a fair question. If derechos are well understood and not especially rare, why did this June feel so relentless, with storm after storm marching across the same ground? The answer is not in any one storm. It is in the larger pattern overhead, the setup in the sky that kept building these storms and aiming them the same way, week after week. The reason this June kept reloading the same weather lies high above the ground, in the river of fast wind that circles the planet. Forecasters call it the jet stream. It flows from west to east, miles up, and it steers the storms below it. Where the jet stream goes, the weather follows. For much of this June, the jet stream settled into a shape that pointed one kind of storm at one part of the country, over and over. That shape is sometimes called a ring of fire, though the name is more colourful than the science behind it. Here is the plain version. A large dome of hot, high-pressure air parked itself over the central and southern part of the country. Air sinks under a dome like that, which is why the middle of it stays hot and dry and calm. But the edge of the dome is a different story. Along its northern rim, the jet stream is forced to bend and ride up and over the heat, and that rim becomes a highway for storms, so the country split into two moods. Under the dome, towns baked in still, heavy heat. Along the rim, just to the north, storm after storm rolled through. The Midwest spent much of June sitting right on that rim. Day after day, the dome held the heat to the south, and day after day, fast storms came skating along its northern edge, aimed straight into the same region. This is why the calendar filled up the way it did. A pattern like this does not produce one big storm and then relax. It produces a fresh round almost every day, because the ingredients reset every afternoon. The sun reheats the ground. The dome pumps warm, moist air up against the rim. The jet stream provides the upper wind to organise it all. By evening, a new complex of storms is ready to ride the rim east, and the cycle repeats. The heat dome did more than steer the storms, it also fed them. The hotter and more humid the air at the surface, the more energy a storm has to work with. A dome of heat sitting next to a storm track is like a full fuel tank parked next to an engine. Every day the dome topped off the tank, and every day a storm came along to burn it. That is why so many of June's storms turned violent rather than ordinary. They were not working with average summer air. They were feeding on the rich, overheated air at the dome's edge. There is a personal way to feel this pattern, away from the maps. People across the Midwest described June as a month that never let them catch their breath. A storm would hit, knock out the power, and down some trees. Crews would start the cleanup. The heat would build back. And before the last branches were hauled away, the radar would light up again with the next round coming. Communities were not recovering from one event. They were absorbing a steady drumbeat of them, on top of the same weakened trees and stressed power lines. That stacking matters for the danger, not just the mood. When a storm hits trees that are already damaged from the last storm, weaker wind can bring them down. When a grid is already patched from the last round of outages, the next round breaks it more easily. The pattern did not just deliver many storms, it delivered them onto ground that each previous storm had already softened, so the damage compounded. None of this means the storms were unnatural or beyond understanding. A heat dome with a stormy rim is a known summer pattern. What was unusual was its persistence. It locked in and stayed, holding the same setup over the same region for weeks rather than days. Patterns usually shift. This one was stubborn, and its stubbornness is the simplest explanation for why one June produced so much. Stubborn patterns leave a mark in the record, and this one did. As the storms piled up, the people whose job is to count these things noticed a number climbing toward territory the modern record had rarely seen. That number, more than any single gust or any single storm, is what put the word unprecedented into the conversation, and it is the next thing to understand. The number that caught the attention of forecasters was not a wind speed, it was a count. Every time a storm produces damaging wind, someone files a report. A trained spotter, an emergency manager, a weather office, all of them log what they see, and those reports flow to the Storm Prediction Centre. Over a month, those reports add up into a running tally of how active the season has been. By the middle of June, that tally was running near the top of the record. Through the first 16 days of the month, the country logged damaging wind reports at the second fastest pace ever measured, in records that reach back to 1955. Only one June had ever started faster. That was June of 2008, a month so active it became a benchmark, which logged more than 3,600 wind reports in the same opening stretch. For 2026 to be running just behind that mark, with storm after storm still coming, was the kind of statistic that makes a meteorologist sit up. It helps to understand what a wind report is and is not. One report does not mean one storm. A single derecho can generate dozens or even hundreds of separate reports as it crosses the map, one for each spot where the wind did damage. So the count is really a measure of how widespread and how repeated the damaging wind has been. A high count means many storms, spread over many places, hitting many people. That is exactly what the Midwest had been living through. There is a record at the end of this road, and forecasters named it out loud. The most active full June ever recorded produced 5,554 wind reports, with 2026 running near record pace and the stormy pattern showing no clear sign of breaking. Some meteorologists began to say plainly that the all-time June record was in reach. They framed it as a real possibility, not a certainty, which is the honest way to put it. A pattern can break in a day, and the chase can end. This is the place to be careful, because this is where the word unprecedented earns its keep, and where it can be misused. The storms themselves were not unprecedented. Derechos and tornado outbreaks are known weather, and the Midwest has seen worse single days than any one day this June. What was unusual, and what the record actually measures, is the relentless pace. It was the sheer number of damaging storms packed into 1 month, hitting the same region again and again. That is the phase that nobody alive has quite seen, and it is a fair thing to say as long as it is said carefully. So when someone says this storm entered a phase nobody has seen before, the truest version is not that the wind broke some law of nature. It is that the calendar did something rare. The region was on track to record more damaging wind in a single June than at almost any time in the 70 years of careful record keeping. The drama is in the accumulation, not in any one gust. It is worth holding both of those truths at once, because they are easy to confuse. Any single storm in June, taken alone, was a serious but ordinary summer storm. The collection of them, taken together, was something the modern record had rarely matched. A listener who keeps that distinction clear will not be frightened by the wrong thing. The right thing to respect is the steady, grinding repetition, and what it asks of the people living under it. Numbers like these are built one storm at a time, and a few of June's storms were big enough to stand on their own. To see how the month reached record pace, it helps to step back from the latest derecho and look at the ones that came before it. The first truly major blow of the month landed in early June, and it set the tone for everything that followed. The first major blow of the month came on the 10th of June, and it was a derecho in its own right. It formed over the upper Midwest and drove east across the Great Lakes, and the National Weather Service later classified it formally with the same word that would describe the storm of the 21st. Its damage path ran more than 400 miles, well past the 250-mile bar, and it carried gusts that topped 90 miles an hour in places. The hardest hit was northern Illinois, including the dense suburbs around Chicago. The afternoon storms there knocked down trees by the thousands and dropped power lines across roads. A brief, weak tornado touched down in the towns of Palos Heights and Alsip, rated at the lowest level on the tornado scale. But the real story that day was the straight-line wind, broad and relentless, doing damage across a wide swath rather than a narrow track. The outage numbers tell the scale better than anything. At the height of the storm, more than 500,000 homes and businesses lost power. Illinois alone accounted for over 300,000 of those, and within Illinois, Cook County, which holds Chicago, lost nearly 200,000 by itself. The darkness spread into Indiana, Wisconsin, and Michigan as the storm rolled through. Days later, the lights were still off for tens of thousands. As of the 13th, around 85,000 customers remained without power in Illinois, and another 57,000 in Indiana. That lag between the storm and the recovery is its own kind of hazard, and it shows up again and again this month. A storm passes in an hour. The cleanup takes days. In June heat, days without power means days without air conditioning, days without working refrigerators, days when the vulnerable, the elderly, the sick, the very young, face a different danger after the wind is gone. The storm of the 10th was a single afternoon, but its effects stretched across most of a week. This storm also took a life, in a way that is sadly common with summer wind. A man in Des Moines, Iowa was killed when a tree fell on him during the severe weather. That detail is worth pausing on because it points to a quiet truth about these storms. Many of the deaths do not come from the dramatic moment of impact. They come from falling trees, from flooded roads, from downed power lines, from the slow, scattered dangers the wind leaves behind. The Storm Prediction Center logged more than 500 separate wind reports from that single event, each one a place where the storm did damage. Set the 10th beside the 21st and a pattern jumps out. Both were derechos. Both ran for hundreds of miles. Both centered their worst on Illinois. Both knocked out power across multiple states. Two storms, 11 days apart, following nearly the same script across nearly the same ground. That repetition is exactly what the record pace number was measuring, and it is exactly what wore the region down. It is fair to ask whether two derechos in one June is itself remarkable. The honest answer is that one derecho in a Midwest June is normal, and a second is not shocking on its own. What stands out is the rhythm of the whole month, the way these major storms kept arriving with so little space between them, each landing on a region still cleaning up from the last. The 10th was not an outlier. It was the opening note of a song that kept repeating, and the derechos were only part of it. Between the big wind events, the same pattern that fed straight-line storms also spun up tornadoes, and the most striking tornado night of the month came in the middle of June. It struck a part of central Illinois that would, by the end of the month, feel as though the sky had singled it out. That night, and one home in particular, shows the other face of this stormy June. The middle of June brought the month's worst tornado night, and it fell on a Wednesday evening across the Midwest. Tornadoes touched down in at least 5 states. Hail the size of baseballs, about 3 inches across, fell from the strongest storms. Wind gusts reached near 80 miles an hour. But the place that took the hardest hit was Effingham County, in central Illinois, where a powerful tornado carved a path more than 20 miles long. The damage in Effingham County was severe and specific. The tornado tracked roughly 12 to 15 miles through the northern part of the county, according to the local emergency agency, and it hit the small communities around the county hardest. In the towns of Shumway and Siegel, the fire department responded to collapsed buildings, badly damaged homes, gas leaks, and crashed vehicles. A popular local museum that housed collectible cars was destroyed. In one moment that captures the storm's force, the wind lifted a vehicle off the ground and hurled it down a street, and the driver was taken to the hospital. One home from that night became a kind of emblem. Video confirmed by news crews showed a house near Effingham completely swept off its foundation and dropped into the road. A county resident describing the destruction said the kind of thing people say when a storm stops being something on the news and becomes the thing that happened to their street. He talked about hearing about tornadoes all the time and then watching real devastation arrive at his own door. That shift from abstract to real is the whole experience of a night like this. Not far away in Charleston, a large tree crashed onto the home of a man named Gabe Surgenet. He had gathered his family into the bathroom when the storm came. He described stacking himself over his youngest son and his girlfriend, with pillows on top ready to lift the whole tree off the house if that was what it took to keep them safe. They came through it. His account is a small lesson in plain form. He picked the safest room in the house, an interior space with no windows, and he put as many walls between his family and the storm as he could. That is exactly the official advice, lived out in a real bathroom in real time. The injuries from that night mercifully stayed mostly minor. In Effingham County, officials described the tornado as impactful, but said the injuries were not serious. In the nearby town of Montrose, another tornado injured 2 people, and their injuries were not life-threatening either. For a night with this much destruction, the survival rate was a quiet victory, and much of the credit goes to warnings that arrived with enough lead time for people to take cover. That same Wednesday carried more than tornadoes. Earlier in the day, a separate line of storms had behaved like a small derecho of its own, tracking some 360 miles in about 7 hours from near Storm Lake, Iowa, down into central Illinois. It knocked a freight train off its tracks near the town of Monmouth, with no injuries or spills, and cut power to tens of thousands. And far to the south, on the very same day, the season's first tropical storm was spinning up near Galveston, Texas. The whole map seemed to be in motion at once. The Effingham tornado is the clearest reminder that this June was not only a wind story. The same overheated, energized air that built the derechos also built the rotating storms that drop tornadoes. They are 2 outcomes of the same fuel. Which one a given storm produces depends on fine details of the wind aloft, but the underlying ingredient, that rich and unstable air, was the same one the heat dome kept supplying. By now a question has been hanging over all of this, raised by the El Reno homes and the toppled trains and the swept-away house in Effingham. How does plain wind, with no funnel, do so much of this damage? People naturally credit a tornado for the worst destruction, yet much of June's harm came from straight-line wind. Understanding the difference between the two is the key to reading this whole month correctly, and it is where this turns next. People tend to credit a tornado for the worst storm damage, but much of June's destruction came from wind that never spun at all. This is one of the most common misreadings in severe weather, and it is worth clearing up directly. When a barn is flattened or a roof is gone, the first guess is often a tornado. Yet across this month, a great deal of that damage was the work of straight-line wind, the broad horizontal blast of a derecho, with no rotation involved. The difference comes down to shape. A tornado is a column of air spinning around a vertical centre, reaching down from a storm to the ground. It is narrow and violent, and it throws debris in a swirl. Straight-line wind comes from a storm's downdraft, the mass of rain-cooled air that crashes down and spreads out along the ground. When that spreading air is strong enough, it becomes a wall of wind moving in one direction. It is wide where a tornado is narrow, and it pushes where a tornado twists. You can read which one struck by looking at how things fell. After a tornado, debris points every which way, scattered by the spin, often along a narrow track only a few hundred yards wide. After straight-line wind, the destruction is broad, sometimes miles across, and almost everything lies down in the same direction, like grass combed flat by a hand. That one-way pattern is the fingerprint survey teams look for, and it is why the Oklahoma and Illinois damage this month was so often labelled straight line rather than tornadic. Here is the part that surprises people most. Straight-line wind can be just as deadly and destructive as many tornadoes. The strongest gust of the late June storm, above 100 miles an hour in Oklahoma, would rate near the middle of the tornado scale if a twister had produced it. The mobile homes destroyed in Illinois were not hit by a funnel. They were pushed apart by straight wind. The damage does not care what shape the wind took. A wall at 100 miles an hour brings a house down whether it is spinning or not. There is even a special name for the most intense pocket of straight-line wind inside these storms. Forecasters call it a downburst, a concentrated plunge of air that hits the ground and blasts outward. A strong downburst can mimic a small tornado in its power, while leaving the telltale outward, fan-shaped pattern of straight wind. Several of the worst hits this month, the kind that drop a roof in a single block, were likely downbursts embedded in the larger derecho. This distinction is not just for scientists. It changes how a person should think about a wind warning. Many people will shelter from a tornado warning but shrug off a severe thunderstorm warning, treating the second as minor. This June showed why that is a mistake. A severe thunderstorm warning for a derecho can carry wind every bit as dangerous as a weak tornado across a far wider area. The people in those Illinois mobile homes faced straight-line wind, and it was enough. The Weather Service has tried to close that gap in understanding with stronger language. When a storm's wind is expected to reach the most dangerous levels, the warning now carries a special tag that marks it as destructive. That tag is meant to cut through the habit of ignoring thunderstorm warnings. It tells people that this particular storm deserves the same respect as a tornado, even if nothing is spinning. Several storms this month carried that tag, so the lesson from the wind side of this June is simple and useful. Do not wait to see a funnel before you take cover. The funnel is only one of the shapes danger comes in. The broad, straight push of a derecho has killed people and levelled homes this month without a single twister at the worst sites. Respect the wind itself, whatever form it takes. To respect it, though, you first have to know it is coming. That is where the forecaster's tools come in. There is a particular shape these storms make on radar, a shape that tells an experienced eye that a wall of wind is on the way. Learning to recognize that shape and the warnings built around it is the difference between being caught asleep and being ready. On radar, a derecho announces itself with a particular shape, and forecasters learn to spot it fast. A line of storms that is producing a strong straight-line wind tends to bow outward in the middle, bending forward like an archer's bow. The bend points the way the wind is pushing. That bowing signature has a name, the bow echo, and when one shows up on the radar screen, it is a clear sign that damaging wind is reaching the ground beneath it. The reason for the bow is the wind itself. Behind the leading edge of the storm, a strong current of air descends and rushes forward along the ground. That rushing air shoves the middle of the storm line ahead of its ends, the same way a strong gust pushes the centre of a sail. The harder the wind, the more pronounced the bow. A sharp, fast-moving bow echo is one of the most reliable warning signs a forecaster has that a line is turning dangerous. Radar does more than show the shape. Modern radar can sense the speed of the wind moving toward or away from it, which lets forecasters see the damaging gusts directly, not just guess at them. When the radar paints a streak of fast inbound wind right behind a bowing line, that is the storm's punch made visible. Combined with reports from spotters on the ground, it gives the warning forecaster the confidence to act quickly, because in a fast-moving derecho there is little time to spare. Speed is the hard part. The storm of the 21st crossed 3 states in a single night. The June 10th derecho ran 400 miles. A storm like that can cover a mile a minute or more. For the people in its path, the window between the warning and the wind can be very short, sometimes only 10 or 15 minutes. That is why forecasters watch the bow echo so closely and issue warnings as early as the data allows. Every minute of lead time is a minute a family can use to get to a safer room. There is a longer warning layer above the short-term ones, and it worked well this month. The Storm Prediction Center draws its risk maps days ahead, rating each region on a scale from marginal up to high. For most of June's big storms, those maps had the right areas flagged a day or more in advance. The general public knew in broad terms that a rough stretch was coming. That early picture does not tell you the exact street that will be hit, but it tells emergency managers, utilities, and schools to get ready, and that readiness saves time when the storm finally forms. The forecasting this June was, by most measures, a quiet success. The patterns were correctly anticipated. The risk areas were drawn well ahead. The warnings, when the storms formed, generally arrived with usable lead time. The Effingham tornado night, with its severe damage but mostly minor injuries, is a case where good warnings clearly helped people survive. The science did its job. The hard part was never the forecast. The hard part was the night, the sleep, and the limited shelter for those most exposed. Still, it is honest to name the limits. Radar cannot see every gust. A brief, intense downburst can hit a single neighbourhood before any warning catches it. Overnight storms strike when people are least able to respond, and no forecast can place a sturdy basement under a mobile home that does not have one. The tools have grown remarkably sharp, but they end where physics and human sleep begin. All of this radar science and forecasting feeds into a handful of words that reach the public, the watches and warnings that buzz on a phone. Those words carry precise meanings, and in a fast storm, knowing the difference between them can decide what a person does in the next 10 minutes. Sorting out what each one actually means is the practical heart of staying safe, and it is the right place to pause the first half of this story. The words that reach the public in a storm carry exact meanings, and knowing them is the most practical safety skill there is. The two that matter most are watch and warning, and people mix them up constantly. A watch means the conditions are right for dangerous weather to form. A warning means the dangerous weather is happening now or about to, and you should act. The simplest way to hold it is to think of cooking. A watch is the oven heating up. A warning is the fire alarm. A severe thunderstorm watch goes out hours ahead, over a wide area, when the atmosphere looks ready to produce damaging storms. It is a heads up, not an alarm. It is the moment to bring in the patio furniture, charge the phone, and decide where you would shelter if you had to. This June, those watches often covered millions of people at once, stretching across whole states, because the threat itself was that broad. A severe thunderstorm warning is the sharper signal. It means a specific storm is producing, or is about to produce, damaging wind or large hail right now in a defined area, usually for the next 30 to 60 minutes. This is the one people too often ignore, thinking thunderstorm means ordinary. This month proved why that is dangerous. The wind that killed people in Illinois and wrecked homes in Oklahoma came under thunderstorm warnings, not tornado warnings. When one of these is issued for your area in a Derecho setup, it deserves real respect. To fix exactly that habit, the Weather Service adds a tag to the most serious warnings. A warning can be labelled with a damage level. The highest level uses the word destructive, and it is reserved for storms expected to produce the most violent wind, around 80 miles an hour or more, or very large hail. A destructive tag does something useful on a phone. It triggers the same kind of emergency alert that a tornado warning does, the loud one that overrides a silent setting. It is the system's way of saying this thunderstorm is as dangerous as a twister, so treat it that way. There is one more level of language worth knowing, mostly seen with tornadoes but telling about intent. The most urgent tornado warnings can carry the phrase particularly dangerous situation. Forecasters reserve that for the rare nights when strong long-track tornadoes are likely, and lives are clearly at stake. Seeing that phrase is a signal to drop everything and shelter immediately. It is not used loosely, which is exactly what gives it weight when it does appear. The practical takeaway from all this language is short. When a watch is issued, prepare. When a warning is issued, act. When a warning carries a destructive tag or a tornado warning carries that most urgent phrase, act immediately and do not wait to confirm it with your own eyes. In a storm moving a mile a minute, the time you spend looking out the window is time you needed to reach the safer room. And the safer room is the same in almost every case, which makes it easy to remember. Go to the lowest floor, get to the most interior room, the one with the most walls between you and the outside. Stay away from windows. A basement is best. If there is none, a bathroom or closet near the centre of the building works. The goal is simple. Put as much building as you can between yourself and the wind, and stay there until the warning is lifted. That guidance is the same whether the threat is a tornado or the straight-line wind of a derecho, which is part of why it is worth knowing cold. A person who hears a warning and moves to an interior room without hesitating has done the single most effective thing available to them. The man in Charleston who put his family in the bathroom under pillows did exactly this, and his family came through a tree falling on the house. That covers the storm itself, from its birth on the Kansas heat to the words that warn of it. But a derecho does not act alone. It arrives with heat, with rain, with floods, and it lands on a power grid and a landscape already strained by everything that came before. The second half of this report turns to those wider effects, starting with the dome of heat that built the fuel for all of it. The dome of heat that steered this June storms also built the fuel that made them violent, and it is worth understanding on its own. A heat dome is a large area of high pressure that parks over a region and holds warm air in place. Air sinks under it, and sinking air heats up and dries out. That is why the centre of a heat dome is hot, still, and cloudless. The middle of the country spent much of this month under exactly that kind of lid. Inside the dome, the danger is the heat itself. Day after day of high temperatures, with warm nights that give no relief, stress the body and the power grid at the same time. That heat is a hazard in its own right, and it tends to take lives quietly, away from any single dramatic moment. But the dome's effect on the storms is what ties it to this report, and it works at the dome's edge rather than its centre. Picture the dome as a wall of warm, heavy air. Storms cannot punch through the middle of it, where the sinking air smothers them. Along the northern edge, though, the jet stream rides up and over the top, and that is where storms are not only allowed but encouraged. The dome acts like a ramp. Warm, moist air is lifted along its rim, and storms fire there and ride the upper wind eastward. The hotter the dome, The sharper that edge, and the more explosive the storms that form along it. There is a holding effect too, and it adds to the violence. The warm air at the top of the dome can act like a lid on the atmosphere, capping the rising warm air below for much of the day. That cap traps energy near the ground. It builds and builds like pressure under a held lid until something finally breaks the cap in the late afternoon. When it goes, all that stored energy releases at once, and storms explode upward in a hurry. A capped, overheated atmosphere that finally breaks tends to produce the most intense storms of all. This explains the daily rhythm the Midwest lived through. Each morning, the sun reheated the ground under clear skies at the dome's edge. Each afternoon, the energy built under the cap. Each evening, the cap broke and storms erupted, then organized and rode the rim east overnight. The next day, the cycle reset. The heat dome was not a separate story from the storms. It was their engine, refueling them every single day. The pairing of heat and storms also stacked the dangers on the people in the middle. A town could spend the day baking under the dome's heat, then take a violent storm at night, then lose power, then face the next day's heat with no air conditioning. The hazards did not take turns politely. They piled onto the same communities, and the heat made the recovery from each storm harder and more dangerous than it would have been in milder air. Forecasters watched the dome closely because its strength and position set everything else. As long as it held in roughly the same place, the storm track stayed parked over the same region, and the Midwest kept getting hit. A shift of the dome by a few hundred miles would have moved the storms to a different part of the country. For weeks, it barely shifted. That stubbornness, more than any single ingredient, is why one region absorbed so much. The heat dome, then, is the quiet center of this whole story. It steered the storms with its edge, fueled them with its heat, intensified them with its cap, and held the whole setup in place long enough to fill a record book. Every derecho and every tornado this month was in a sense a product of that dome. Understanding it turns a confusing run of separate storms into a single sensible pattern. But the storms born at the dome's edge did not bring only wind. They carried enormous amounts of water, wrung out of that warm, moist air, and they dropped it on ground that had no more room to take it. The flooding that ran alongside the wind was a hazard of its own, and in some places it arrived at the very same moment as the gusts. That double blow, wind and water together, is the next thread to follow. The same warm, moist air that fueled the wind also carried a heavy load of water, and the storms wrung it out fast. Warm air holds more moisture than cool air. The overheated air at the dome's edge was loaded with it, and when storms tapped that air, they produced rainfall rates that overwhelmed the ground in minutes. In the worst cells this month, rain fell at more than 2 inches an hour. That is a rate that turns streets into streams almost as fast as it starts. Flash flooding is the name for water that rises quickly, and the word flash is the important part. It does not build over days like a river flood. It arrives in minutes, when rain falls faster than the ground and the drains can carry it away. A road that is dry can be under a foot of moving water before a driver understands what is happening. That speed is what makes flash flooding so deadly. People are caught in it before they judge it as a threat. This June, the flooding often came hand in hand with the wind, which is an unusually cruel combination. In one morning round across Illinois, a fast line of storms brought damaging straight-line wind and torrential rain at the same time. People faced both hazards at once. The wind was downing trees and lines, while the rain was filling low spots and overwhelming storm drains. Either alone is dangerous. Together they leave fewer safe choices because the route away from one hazard may run straight into the other. The ground made it worse, and this is where the month's repetition shows up again. Weeks of storms had already soaked the soil across much of the region. Saturated ground cannot absorb new rain. It simply sheds it, sending nearly all of it running off into creeks, ditches and streets. So each new storm dropped its rain onto land that was already full, and the runoff was faster and higher than it would have been on dry ground. The flooding compounded the same way the wind damage did, each storm building on the last. The standard safety guidance for flooding is short and saves lives, so it is worth stating plainly. The rule is simple: turn around, do not drown. Never drive into water of unknown depth across a road. It takes only about a foot of moving water to float many cars, and about 2 feet to carry away most vehicles, including trucks. The water also hides what the road beneath it is doing. A washed-out road looks the same as a passable one when both are under brown water. The only safe choice is to find another route. Flooding tends to be underestimated because it lacks the drama of a tornado or the noise of straight-line wind. It does not roar. It does not leave a bow echo on radar in the same vivid way. It rises quietly, often at night, often on familiar roads that people have crossed 1,000 times. That very ordinariness is the danger. A driver who would never approach a tornado will drive into floodwater because the road looks merely wet, and that misjudgment is one of the most common ways people die in storms like these. This month's flooding did not produce the headline losses that the wind did, but it added steadily to the strain. It closed roads that emergency crews needed. It slowed the cleanup. It put water in basements that had only just dried out from the last round. It was one more way the pattern ground down the region, working in the background while the wind took the attention. Wind and water together did their damage in a single night and moved on. But they left behind a problem that lasted far longer than the storm. Across the region, the power went out, and it stayed out, for hundreds of thousands of homes at a time. In June heat, a long outage is not an inconvenience. It is a hazard of its own, and it is the next piece of the storm's true cost. The lights going out is where a storm's damage stretches from minutes into days. The June 10th Derecho alone cut power to more than 500,000 homes and businesses at its peak. The late June storm darkened tens of thousands more. Across the month, outage maps glowed with the same regions losing power again and again. The wind passes in an hour, but the darkness it leaves can last most of a week, and in summer, that darkness carries its own danger. The cause is simple and physical. Power lines hang from poles and run through trees. Strong wind snaps the poles, drops the lines, and brings tree limbs crashing down across the wires. A single derecho can do this across hundreds of miles at once, knocking out power in thousands of separate spots. That scatter is what makes restoration so slow. Crews are not fixing one big break. They are chasing thousands of small ones spread across a huge area, often on roads still blocked by the very trees that caused the outage. The math of restoration is why patience runs thin. After the June 10th storm days later, tens of thousands of customers were still in the dark. Around 85,000 in Illinois and 57,000 in Indiana remained without power on the third day. Utility crews work long shifts, and crews come in from other states to help, but there is a hard limit to how fast hundreds of thousands of connections can be restored when each one must be reached and repaired by hand. In June, an outage is more than darkness. It is the loss of air conditioning during a heat dome, when temperatures stay high day and night. For most people, that is misery. For the vulnerable, it can be deadly. The elderly, the very young, people with certain illnesses, and anyone dependent on powered medical equipment face real risk when the cooling stops and the heat does not. This is the quiet overlap of the month's two big hazards. The heat that fueled the storms also made the outages they caused more dangerous. There is a cascade of smaller losses inside a long outage too. Refrigerators warm and food spoils. Wells that run on electric pumps stop, leaving some rural homes without water. Phones run down with no way to charge, cutting people off from the next round of warnings. Traffic lights go dark, making roads more dangerous. Each of these is minor on its own. Together, across days, they wear down a community's ability to cope and to stay informed about the next storm already forming. The repetition this month made the grid problem worse than any single storm would suggest. A power system that has just been patched after one derecho is more fragile when the next one arrives. Trees weakened but not yet downed by one stormfall in the next. Equipment stressed by one round fails in the following one. The grid, like the trees and the soil, never got a full chance to recover before the next blow landed. The practical advice for a long outage is steady and unglamorous. Keep phones charged before a storm arrives. Have a way to receive warnings that does not depend on the grid, such as a battery weather radio. Keep water and non-perishable food on hand. Check on elderly neighbours during heat, because a hot, dark home can become dangerous before the person inside realises it. None of this stops the wind. All of it softens the days that follow. The grid is one kind of infrastructure the wind breaks, but it is not the only one. The same force that drops a power line can push a freight train off its tracks and drop a century-old tree across a road. The damage to the physical bones of a region, The rails, the trees, the lines shapes how long recovery takes and how dangerous the aftermath becomes. That broader damage is worth looking at directly. Wind strong enough to topple a freight train tells you something words alone cannot. Twice this month, Derecho's pushed loaded rail cars off their tracks, once near Monmouth, Illinois, during the mid-June storms, and again in Woodward County, Oklahoma, during the late June derecho. In the Oklahoma case, a stretch of cars about a mile long was blown over. These are not light objects. A loaded rail car weighs well over 100,000 pounds and sits low and stable by design. It takes a broad, sustained wall of wind to lay one down, let alone a mile of them. The train derailments matter beyond the spectacle because of what trains often carry. Some of the toppled cars in Oklahoma bore placards marking hazardous material. When cars like that go over, the first fear is a leak, a spill, or a fire near a community. This month, that fear did not come true. No leaks were reported in either derailment, and no one was hurt. But the placards are a reminder that a wind event can become a chemical emergency in an instant, and that the people who respond to these storms have to plan for that possibility every time. Trees are the other great casualty of straight-line wind, and they cause more trouble than their falling alone suggests. A derecho can bring down trees by the thousands across its path. Those trees take power lines with them, block the roads that crews need to reach the damage, and crush the homes and cars beneath them. The man killed in Des Moines earlier this month died when a tree fell on him during the storm. Trees are not a side effect of the wind. They are one of its main ways of doing harm to people. There is a reason trees fall the way they do in these storms, and it ties back to the month's relentless pattern. A tree in full summer leaf catches far more wind than a bare one. The leaves act like a sail, so a healthy summer tree takes the full push of the gust. Add ground already soaked by weeks of rain, which loosens the root's grip, and a tree that would stand in a dry spring wind topples in a wet June one. The saturated soil that fed the flooding also helped fell the trees. The repetition stacked this damage too, in a way that made later storms more destructive than their wind alone would explain. The first derecho weakened countless trees without fully downing them, leaving them cracked, leaning, or half-rooted. The next storm finished the job, dropping trees that a single event might have spared. The same was true of the grid and of buildings already stressed. By late June, the region's physical defences were worn thin, so each new storm met less resistance and did more harm. The aftermath of all this is its own slow hazard, and it lasts long after the sky clears. Downed power lines may still be live and deadly. Damaged trees can drop heavy limbs without warning during cleanup. Roads stay blocked, slowing ambulances and repair crews alike. Most storm-related injuries, in fact, come in this aftermath rather than during the storm itself. From chainsaws, from falls, from contact with live wires, from carbon monoxide when people run generators in enclosed spaces. The danger does not end when the wind stops. The standard guidance for the aftermath is plain and important. Treat every downed line as live. Stay away from it and report it. Do not run a generator indoors or in a garage, ever, because the exhaust can kill silently. Be cautious around damaged trees and structures. The storm has passed, but the wreckage it left is still capable of taking a life, and the recovery period is when many of them are lost. All of this damage piling up across 1 month over one region naturally leads people to ask a larger question. Is this just weather, a stretch of bad luck in the atmosphere, or is something deeper shifting that made this June what it was? It is a fair question, and a careful one, and it deserves an honest, measured answer rather than a quick one. A month like this naturally raises the question of climate, and it deserves a careful answer rather than a quick one. The honest place to start is with the limits of what any single month can tell us. Weather is what happens over days and weeks. Climate is the long-term average over decades. One stormy June, however extreme, is a weather event. It cannot by itself prove or disprove anything about the long-term climate, and anyone who claims otherwise in either direction is overreaching. What scientists can speak to with more confidence is the background conditions, and here the picture is clearer. A warmer atmosphere holds more water vapour. That is basic physics, well established and not in dispute. More moisture in the air means more fuel available for thunderstorms and heavier rainfall when they form. The torrential rain rates this month, more than 2 inches an hour in places, are the kind of heavy downpour that a moister atmosphere makes more likely. On rainfall intensity, The connection to a warming climate is reasonably well supported. The wind side of the story is harder, and honesty requires saying so. Whether a warming climate produces more derechos or stronger ones is an area of active research without a firm answer yet. The ingredients are complex. Derechos need not only warm, moist air, which warming tends to increase, but also particular wind patterns aloft, which warming may change in ways that are not yet clear. So on the specific question of whether this month's wind events are part of a trend, the careful answer is that we do not yet know. The persistent pattern itself, the stubborn heat dome that parked over the country and would not move, is another piece scientists are studying. There is ongoing research into whether a warming world makes weather patterns get stuck more often, holding the same setup in place for weeks the way this June's did. It is a serious line of inquiry, but it is not settled. Pointing to this one stalled pattern as proof of that idea would be getting ahead of the evidence. It helps to separate two things that often get blurred together. The first is whether extreme weather is happening. That is simply observed, and this June it plainly was. The second is attribution, the question of how much a warming climate contributed to a specific event. Attribution is real science, and it can sometimes be done, but it takes careful study after the fact, not a snap judgment during the storm. The right time to ask how much climate shaped this June is later, with the data in hand, not in the heat of the moment. The measured summary is this: a warming atmosphere loads the dice toward heavier rain and gives storms more fuel, and that is well supported. It probably contributed to the intensity of the rainfall this month. Its role in the wind events and the stuck pattern is genuinely uncertain and under study, and no part of this single month can stand as proof of a trend by itself. That is not a dodge, it is simply where the evidence honestly sits. This careful stance is not less useful than a bold claim. It is more useful because it tells you what to actually do. Whatever the long-term cause, the near-term reality is that this region just absorbed a brutal month of storms, and more could come. The response that makes sense, better warnings, sturdier shelter, readiness for outages, is the same whether the deeper driver is natural variability, a warming climate, or some mix of both. The practical path forward does not wait on the attribution question to be settled. So the climate question, asked honestly, does not deliver a dramatic verdict. It delivers a measured one, and a measured verdict is the right kind for a report meant to inform rather than alarm. To get a sense of just how unusual this June really was, though, it helps to set it against the one month that has long served as the benchmark for relentless summer storms. That month was June of 2008, and the comparison is telling. To measure this June, forecasters keep returning to one benchmark, the June of 2008. That month earned a lasting reputation as one of the most relentlessly stormy on record. It logged a staggering count of damaging wind reports, more than 5,500 for the full month, and in its opening 16 days it produced more than 3,600. For 17 years it stood as the standard against which other stormy Junes were measured. When meteorologists this month reached for a comparison, that is the year they named. The reason 2026 drew the comparison is that it kept pace, very nearly. Through the first 16 days, this June ran at the second fastest clip ever recorded, trailing only that legendary 2008. To be running just behind the most active June in 70 years of record keeping, with storms still coming, is what gave the month its sense of history in the making. It was not beating the record outright in those early days. It was shadowing it, close enough that the record came into view. It is worth being precise about what that benchmark measures, because precision is what keeps this honest. The count is of wind reports, not of storms and not of deaths. A high count means damaging wind was widespread and frequent, spread across many places and many days. It does not by itself mean this June was the deadliest or the costliest. Those are different measures, and a record pace of wind reports does not automatically set records in those other columns. The number says the wind was relentless, no more and no less. The comparison also reveals what these two Junies had in common, which is instructive. Both featured a persistent pattern that favoured repeated derechos and widespread wind over a sustained stretch. Both concentrated their worst on the broad Midwest corridor. In both, the story was less about one historic superstorm and more about the steady accumulation of many serious storms with little rest between them. That accumulation is the signature of a stalled, storm-favouring pattern, and it is what both years had in abundance. There is a sobering side to the comparison that should not be lost. The 2008 benchmark was not a gentle one. That summer's relentless storms caused widespread damage and real loss across the country. Matching its pace is not a trivia point. It means the region was living through a stretch as punishing as one of the worst on record. The comparison is not a sports statistic. It is a way of saying that the strain on these communities was near the top of anything the modern record has seen. At the same time, the comparison offers a kind of perspective that calms rather than alarms. This had happened before, within living memory, and the country came through it. The pattern that drives such a month is understood. The benchmark exists precisely because someone measured and recorded that earlier extreme, which means this kind of June, while rare, is not unknown. There is some steadiness in knowing that the present extreme has a clear precedent, and that we have a framework to make sense of it. Whether 2026 ultimately matched or passed 2008 depended on the weeks after the late June Derecho, and that was still being written. A stormy pattern can break suddenly. A few quiet weeks would have left the month short of the record. A continued barrage would have pushed it into first place. The honest statement, made by forecasters at the time, was that the record was in reach, but not assured. That is the proper way to speak of a record still being chased. Numbers and benchmarks, though, can pull attention away from the only thing that ultimately matters, which is the people living under these storms. Behind every wind report is a household that took the gust. The most important part of any storm report is not the record it might break, but the guidance that helps a family come through the next one safely. That guidance, drawn from this month's hard lessons, is where this turns next. Behind every wind report this month was a household, and the most useful thing this report can offer them is plain, standard safety guidance. None of it is complicated. All of it comes straight from official advice, and most of it was demonstrated, for better or worse, in the real events of this June. The aim is simple: know what to do before the storm, during it, and after, so that when the warning comes there is no scramble to figure it out. Start before the storm, on the calm day when a watch or a risk outlook is issued. That is the time to decide where you will shelter, to charge your phones, and to set up a way to get warnings that does not depend on the power staying on. A battery-powered weather radio does this well, and so does an alert app on a charged phone. The single most important step for anyone in a mobile home is decided here, in advance. If a strong wind threat is coming and you live in a mobile home, plan to leave it before the storm arrives, while it is still calm. That point bears repeating because this month proved its weight. The people killed in Illinois were in mobile homes in the dark. A mobile home cannot protect you from straight-line wind near 100 miles an hour, and there may be no time to leave once the storm is on you. The safe move is to identify a sturdy building ahead of time, a neighbour's house, a relative's home, a public shelter, and to go there in the evening when the forecast is bad, not at 3 in the morning when the wind is already at the door. During the storm, the guidance is the same whether the threat is a tornado or a Derecho straight wind. Go to the lowest floor, get to the most interior room, with the most walls between you and the outside. Stay away from windows. A basement is best. A bathroom or closet near the centre of the building is the next choice. The man in Charleston who put his family in the bathroom under pillows did exactly this, and a tree fell on his house while they were safe inside. That is the guidance working in real life. If you are driving when a severe storm hits, the rules change with the hazard. For wind and hail, the advice is to get off the road safely and shelter in a sturdy building if you can reach one. For flooding, the rule is the one that saves the most lives. Turn around, do not drown. Never drive into water across a road when you cannot see how deep it is. A foot of moving water can float a car. The road underneath may be washed out where you cannot see it. After the storm, the danger is not over, and this is where many injuries actually happen. Treat every downed power line as live and deadly. Stay clear of it and report it. Never run a generator indoors or in a garage, because the exhaust can kill silently within minutes. Be careful around damaged trees and weakened structures during cleanup. In June, heat with the power out, check on elderly neighbours and anyone who may struggle without air conditioning, because a hot, dark home can turn dangerous quietly. The thread running through all of this is time. These storms move fast, a mile a minute or more, and they often strike at night. The reason to plan ahead is that the storm does not give you time to plan in the moment. A household that knows its shelter, keeps its phones charged, and acts on a warning without waiting to confirm it has done the most that ordinary people can do. Everything else is in the hands of the forecasters and the wind, which raises a fair and hopeful question about those forecasters. With all the loss this month, did the warning system work, or did it fail the people in its path? The answer is mostly encouraging, and it is worth telling honestly, because it shows both how far the science has come and where its hard limits still lie. With so much loss this month, it is fair to ask whether the warning system worked, and the honest answer is that mostly it did. The forecasts this June were, by the measures that matter, a success. The dangerous patterns were anticipated days ahead. The risk maps drawn by the Storm Prediction Centre placed the threat in the right regions before the storms formed. When the storms did form, the warnings generally went out with usable lead time. The science did close to everything that could be asked of it. The clearest example is the mid-June tornado night in Effingham County. That night produced a tornado that tracked more than 20 miles, destroyed a museum, swept a home off its foundation, and tore through several small towns. With damage that severe, the striking thing is how few people were seriously hurt. The injuries were described as mostly minor. That gap between catastrophic damage and limited loss of life is what good warnings buy. People had time to get to interior rooms and they used it. The system has specific tools that worked as designed this month. The destructive tag on the most dangerous thunderstorm warnings triggered the loud emergency alerts on phones, the kind that override a silenced setting for several of the worst storms. The longer-range risk outlooks gave emergency managers, utilities, and the public a day or more to prepare. The bow echo on radar let forecasters see the derechos organising and warn ahead of the wind. Each of these did its job when it counted, but honesty requires naming the limits too, because the system is not magic, and 3 people still died. The hardest limit is the overnight storm. The late June derecho struck southern Illinois in the small hours when people are asleep and least able to respond. A warning that buzzes a phone on a nightstand only helps if it wakes the household, and then only if that household has somewhere safer to go. Both of those failed for the people in those mobile homes through no fault of their own. A second limit is shelter, and no forecast can overcome it. The warning can be perfect and still not save someone who has no safe place to take it. A mobile home in open country offers little protection from straight-line wind, and the warning cannot conjure a basement that does not exist. This is why the guidance for mobile home residents is to leave in advance. The system can tell you the storm is coming. It cannot make your home strong enough to ride it out. A third limit is the brief local hazard that radar cannot fully see. A sudden downburst can hit a single neighbourhood faster than any warning can reach it. A weak tornado can touch down and lift within a couple of minutes. The tools have grown remarkably sharp, but they cannot catch every gust in every block, especially the smallest and fastest ones. There will always be a margin where the storm moves faster than the warning. The fair conclusion is a balanced one. The warning system this June performed well, and it saved many lives, almost certainly far more than were lost. The Effingham night is proof of what good warnings do. The losses that did occur came mostly at the edges of what any warning system can reach. In the dark, in fragile shelter, in the fastest local hazards. That is not a failure of the science, it is the honest boundary of it, and naming that boundary clearly is part of respecting both the forecasters and the people they serve. All of this brings the story back to the phrase that started it, the claim that this storm entered a phase nobody has seen before. With the full month now laid out, from the heat dome to the warnings, it is finally possible to weigh that phrase honestly. It turns out to be partly true and partly overstated, and sorting out which is the heart of an honest report. It is time to weigh the phrase that opened this report, the claim that the Midwest storm entered a phase nobody has seen before. With the whole month now laid out, that phrase can be judged honestly, and the honest verdict is mixed. Part of it is true, and an important part of it is overstated. Separating the two is the most useful thing this report can do, because the difference is the difference between being informed and being alarmed. Start with what is not unprecedented, because that is where the overstatement lives. The storms themselves were not beyond anything ever seen. Derechos are known. well-understood storms. The Midwest gets them most summers. Tornado outbreaks are a familiar part of the season. The single worst day this June was a serious storm, but the region has seen worse single days in its history. No law of nature was broken, no new kind of storm appeared. Each individual event, taken alone, was a severe but ordinary product of a summer atmosphere. Now turn to what is genuinely unusual, because that part is real and deserves respect. It is the pace. Through its first 16 days, this June produced damaging wind reports at the second fastest rate ever measured, in records going back to 1955. It was shadowing the most relentless June on record. That accumulation, storm after storm hammering the same region with so little rest between them, is the thing the modern record has rarely matched. The phase nobody has quite seen before is the relentlessness, not the storms. So the truest version of the phrase is this: the Midwest did not enter some supernatural new kind of weather. It entered a stretch of weather that was historically relentless, a month on track to set or nearly set a 70-year record for how often damaging wind struck. The drama is in the calendar, not in any single gust. A listener who holds that distinction will worry about the right thing. The right thing to respect is the grinding repetition, and what it asked of the people underneath it. This distinction matters for more than accuracy. It matters for how a person feels and what they do. To say a storm broke all the rules of nature invites fear and helplessness, and it is not even true. To say the region absorbed a historically relentless month of known storms invites something more useful, a clear-eyed respect for the pattern and a focus on the practical steps that actually help. The honest framing is also the more empowering one. It is also worth noting how the phrase reflects a habit worth resisting. Storm coverage often reaches for the most dramatic words, the unprecedented, the never-before-seen, because those words hold attention. But the steady truth holds attention too, and it holds it better over time, because it does not collapse the moment a listener checks the facts. The accumulation this June was remarkable enough on its own. It did not need inflating, and inflating it only makes the real story harder to trust. There is a quieter point underneath all of this, about how to listen to extreme weather news in general. When a headline says a storm has entered a phase nobody has seen before, the useful response is not to panic and not to dismiss it, but to ask what specifically is unusual. This month, the specific answer was the pace of damaging wind reports approaching a record. That is a real, measurable, meaningful thing. It is also a calm thing once you understand it. The work of a good report is to find that calm, specific truth inside the dramatic phrase. That truth, found and stated plainly, is most of what there is to say about the month behind this storm. What remains is the future, the part no one can confirm yet. A stormy pattern this stubborn does not vanish on a schedule, and the days after the late June Derecho carried their own risks and their own uncertainty. What the week ahead held, and how to think about it honestly, is the next thread. A pattern this stubborn does not switch off on a schedule, and the days after the late June Derecho carried their own risk. In the honest language of a forecast, the threat was not over. The same broad setup that drove the month, the heat dome and its stormy rim, was still in place as the late June storm cleared, and forecasters were pointing to more rounds of severe weather and flooding in the days that followed. The region was not promised a rest. The near-term outlook described a familiar rhythm. Severe storms were expected to keep frequenting the plains, with additional rounds sweeping into the east and the south. A risk of strong wind gusts, hail, and flooding downpours was forecast to be scattered across parts of the Great Lakes, the Mid-Atlantic, and the central states. In other words, more of the same kind of weather the month had already delivered, riding the same patterns along the same edges. The specifics would shift day to day, but the overall character held. The heat side of the pattern was forecast to build as well, and that is its own hazard worth naming. As a large dome of heat strengthened over the middle of the country, the conditions favouring fast-moving derechos were expected to persist over the Midwest. The same dome that brought dangerous heat to the centre would keep sharpening the storm track along its edge. Heat and storms, once again, were set to arrive as a pair rather than take turns. It is important to mark these forward-looking statements clearly for what they are. They are forecasts, not confirmed events. A forecast of more severe weather is a statement of elevated risk over an area, not a promise that any particular town will be hit. The honest way to hold it is to treat it as a reason to stay ready, not a reason to be afraid. The risk was real and worth respecting. The exact outcome was still unwritten as the late June storm cleared. This is also where the honest uncertainty of weather should be embraced rather than hidden. Forecasts grow less specific the further out they reach. A few days ahead, forecasters could see the general threat clearly. Whether the stormy pattern would hold for weeks or finally break was genuinely uncertain, and the people whose job is to say so said exactly that. A stubborn pattern can persist longer than expected, or it can break down in a matter of days. Both remained possible. For the people in the region, the uncertainty does not change the practical response, which is steadying in itself. The steps are the same ones this report has returned to throughout. Keep away to get warnings. Know where you will shelter. Have a plan for a long outage in the heat. Watch the daily forecasts because in a pattern like this the threat resets each afternoon. None of this requires fear. All of it requires a kind of calm, ongoing readiness, the posture of a region that knows the season is not done with it. There is a measure of reassurance in the structure of the threat too. This was not an unknown danger, but a known one repeating. The forecasters understood the pattern. The warning system had shown all month that it works. The guidance for staying safe was clear and proven. Facing more of a familiar threat with good tools and clear advice is a far better position than facing something genuinely unknown. The week ahead held risk, but it held no mystery. What the week ultimately delivered, and whether the month closed as a record or merely a near record, would only be known once it was over and the counting was done. That counting is not a small thing. It is how an extreme month gets turned into a fact that the next generation of forecasters will measure against. How the records actually get tallied, and what this June's final numbers might show, is worth understanding as the story nears its close. Once a month like this ends, the work of counting begins, and that counting is how an extreme becomes a fact. Through the storms themselves, the numbers are preliminary. Wind reports come in fast and rough, from spotters, emergency managers, and weather offices, and they are logged in real time to track the threat as it unfolds. Those running totals are what fueled the record pace headlines this month. They are useful and broadly accurate, but they are not yet the final word. After the storms, the careful work takes over. Survey teams from the National Weather Service walk the damage in person. They measure the length and width of each damage path. They study the direction things fell to tell straight-line wind from a tornado. For tornadoes, they assign a rating on the scale that runs from the weakest to the most violent, based on the damage left behind. For derechos, they confirm whether the wind path met the official thresholds of length and strength. This is how a preliminary report becomes a confirmed one, and it can take days or weeks. That gap between preliminary and confirmed is worth understanding, because numbers can shift in both directions. Some early reports turn out to be duplicates of the same gust seen by two observers, and the count comes down. Other damage is found that no one reported in the moment, and the count goes up. A storm first called a possible tornado is sometimes confirmed as straight-line wind, or the reverse. The final tally is more accurate than the live one, but it arrives long after the headlines have moved on. For this June, that means the dramatic figure, the second fastest pace on record, was a preliminary number, honestly reported as such. Whether the month ultimately set the all-time June record for wind reports, matched it, or fell just short would be settled later, after the surveys were done and the duplicates cleared and the late-found damage added. The record was in reach through the storms. The official answer would come from the patient counting afterward, not from the live totals that made the news. This patient process is not a weakness in the reporting, it is the backbone of it. The reason forecasters could say this June was running near a 70-year record is that someone counted carefully in all those earlier years, including the benchmark June of 2008. Today's careful counting is what will let a forecaster decades from now place a future stormy month in context. The record book is only as good as the discipline that fills it, one confirmed survey at a time. There is something steadying in that discipline, set against the noise of an extreme month. The storms are loud, fast, and frightening in the moment. The counting is quiet, slow, and exact. It does not inflate, and it does not panic. It simply measures what happened and writes it down accurately, so that the truth of the month outlasts the fear of it. In a sense, the survey teams walking the damage are doing the same thing this report tries to do, replacing the dramatic first impression with the careful, true one. So the final scale of this June will be known, just not immediately. In time, the confirmed count of the wind reports will tell us whether the month earned its place near the top of the record, or at the very top. The tornado ratings will tell us how strong the Effingham Twister and the others truly were. The damage totals will tell us the full cost. Those facts are coming. They are simply being gathered with the care that real facts require. That care is the right note to end on, because it points to what a report like this is ultimately for. The whole purpose of laying out one storm and the month around it, plainly and accurately, is to leave a listener informed rather than rattled. With the story now told in full, from the first gust in Kansas to the counting still to come, only one thing remains, which is to gather what is known, mark what is still uncertain, and name the next thing worth watching. So this is where the story stands, gathered into what is known, what is uncertain, and what comes next. On the night of the 21st, a derecho ran out of southwest Kansas, peaked above 100 miles an hour over Oklahoma, and reached southern Illinois by dawn, where it destroyed mobile homes and took 3 lives. That is the confirmed core of it. A train was blown off its tracks in Oklahoma. Homes in El Reno were reduced to rubble. Survey teams confirmed the storm met the definition of a derecho. Those facts are settled. The wider month is known too, and it is the real story. This June brought one major windstorm after another to the same tired region. An early June derecho cut power to more than 500,000 homes. A mid-June tornado night tore through Effingham County and swept a house off its foundation. Through it all, damaging wind reports piled up at the second fastest pace ever recorded, going back to 1955. The region absorbed a historically relentless stretch of storms, and that relentlessness is what made this month stand apart. What remains uncertain is worth stating just as plainly, because honesty about the unknown is part of an honest report. Whether the month set the all-time June record for wind reports, or fell just short, would only be settled by the careful counting that follows the storms. How much a warming climate shaped this June is a real question for later study, not a verdict for today. And whether the stubborn pattern would hold or break in the days ahead was genuinely unsettled as the late June storm cleared. These are not dodges. They are simply the things not yet known. The phrase that opened this report can now be set in its proper place. The Midwest did not enter some supernatural new kind of weather. It entered a stretch of known storms that was historically relentless, a month near the top of a 70-year record for how often damaging wind struck. The storms were ordinary in kind and extraordinary in their accumulation. That is the truest version of the story the title was telling, and it is a calmer truth than the phrase first suggests. The next thing to watch is the pattern itself. As long as the heat dome holds and the jet stream keeps riding its northern edge, the Midwest stays in the path, and the daily threat resets each afternoon. When the dome finally shifts or weakens, the relentless rhythm breaks, and the region gets its rest. That shift, whenever it comes, is the single most important thing to watch in the days after this storm. Until then, the season is not finished with the region. For anyone living under it, the response stays the same, and it is a calm one. Keep a way to get warnings that does not depend on the power staying on. Know where you will shelter before the storm arrives. If you live in a mobile home and a strong wind threat is coming, plan to leave for a sturdy building while it is still calm. Treat a destructive thunderstorm warning with the same respect as a tornado warning. None of this is fear. All of it is readiness, and readiness is what carries a person through a season like this one. That is the whole of it, told in order and without inflation. One storm, born on the heat in Kansas and ending in loss in Illinois. 1 month around it, relentless enough to approach a record that has stood for 17 years. A warning system that mostly worked, and the hard limits where it does not. And a pattern still overhead, holding the region in its path a while longer. The facts are serious, and they are also understood, and there is a steadiness in understanding them. The storms will keep being counted, the surveys will keep being walked, and the record book will keep its honest tally. When the next significant event arrives over this region or another, this report will be here to walk through it the same way, calmly and in order. Until then, stay aware, stay ready, and keep an eye on the pattern overhead. The next report will be along when the weather calls for it.